Yes, friends. Guys, now I'm taking theorems of probability. Okay, now these questions are based on theorems of probability. Very important topic. What are the theorems of probability? I'll describe them, I will talk about them, and first I'll explain that what are these theorems. And then you will realize that, okay, whatever questions we have done up to now in the previous lecture series, some of them were based on these two theorems. Now, the scheme will be very clear. I mean, the basics of probability will be further clarified. Reason is that after going through these two theorems, there are two theorems of probability. First is addition theorem, second is multiplication theorem. And how these two theorems are applied and how questions are calculated or based upon these two theorems are solved, that I am going to describe here. These questions are based on these two types of theorems. Okay, so and after that you will just, after going through this whole lecture series, you will come to know about that yes, this topic is very important so far as probability is concerned, right? So basic theorems of probability are what? So what are the basic theorems of probability? First let me describe them, and after that I'll take them. And as I have told you that this probability topic is very important for almost all kinds of students. Competitive examinations for science students, for arts students, for BSc, for MSc, for management students is must. Okay, for management students, because I am teaching for MBA students, MBA and MCA students. In management students courses, there is quantitative techniques or quantitative methods. Okay, in quantitative methods or quantitative techniques for management students, this is a very important topic, right? Because conditional probability, Bayes theorem, and these theorems, binomial distribution, very important. Okay, I will describe them one by one. But competitive examinations, all the questions which I have described in the previous two lecture series, they were based on competitive examinations. They are also applicable for almost all kinds of other courses also. So please don't think that these are especially for this and that. No, all are mixed. Okay, because but I have, my main objective is just to clarify the topic so that one can understand with sound knowledge of this topic, right? One can understand how to solve the questions based on probability. Okay, and for that I have just clarified that what is combination and permutation formulae in the previous lecture series, and after that I am taking this probability. So because probability is calculated with the base of sometimes combination formula, sometimes permutation formula, and sometimes without those two formulas based on these theorems. So let me take these theorems now. Okay, first theorem, what are the theorems? So there are two important theorems. There are two important theorems of probability. Important theorems of probability, which are those. Number one is addition theorem. Addition theorem. Okay. And the second is multiplication theorem. Very important. Multiplication theorem. And for them, let me take the basics of these, how these theorems are defined. Basically, these two theorems are based on, let me take what are the important trials of this question, okay, or important rules. First, let me take this rules of theorems, or rules for these theorems. Rules for these theorems. Okay, first is, there are two kinds of, basically, as I told you. First theorem, second theorem. This is for addition rules. Rules for these theorems. First I am talking about addition rules. What are the addition rules? Let me talk about them. Addition rules means, when the addition rules are done, they are used for simultaneous occurrence of trials or events. Therefore, for simultaneous occurrence, addition rules are for simultaneous simultaneous trials. Okay, simultaneous trials, and this is, we are now multiplication rules. Multiplication rules. They are for consecutive trials. What are the consecutive? One after the other. Consecutive trials. Try to understand this point. Consecutive and simultaneous. These two basic parts are there. Multiplication rules are for, I'll take this whole. Multiplication rules are for consecutive trials. And these are for simultaneous occurrence of trials. Simultaneous trials or simultaneous occurrence of trials. They are a consecutive occurrence of trials, one after the other. They are together, they are happening. Okay, so addition rules are applied for these two. Now then, what are the basic rules? They are further divided into two parts. These are also divided into two parts. Basically, these two parts are, let me take these two parts. First, this part. Second, here in case of multiplication. And in case of addition also there are two parts. I'll describe them again and again, so don't worry why I'm taking them in brackets like this. Okay. Now the addition rules are applied for mutually exclusive events and sometimes partially overlapping events. There are two kinds of events here. They are mutually exclusive events. Mutually exclusive events. These are exclusive events or mutually exclusive events. They are mutually overlapping, some partially overlapping, not mutually exclusive, but they are partially overlapping. Try to understand. Overlapping. So there are two types of addition rules for mutually exclusive events or mutually exclusive events, right? And these are partially overlapping events. So there are two types of addition theorems. Addition theorem applied for two types of events or trials. Which are those two trials? When the two events which are simultaneously occurring, they are mutually exclusive. Nothing is common between them. And here, partially overlapping means something is common between them. So some common, they are exclusive, but as well as they are not exclusive. Partially they are overlapping. This is partially overlapping. Let me write it again. This is partially overlapping. Partially overlapping. Try to understand. These are partially overlapping trials. For them, addition rules are applied, and in both cases, there are four kinds of formulae are used. Two types of for addition, and two types of events are there for multiplication. First, I'll take independent events here. Those consecutive events are independent events. Independent events or trials. When the event two or more than two events are independent. When occurrence of one event is not affecting the occurrence of another event, they are independent events. And they are dependent. Second case is dependent events. When occurrence of one event is affecting dependent events. There are two portions or two types for multiplication rules. So two types of multiplication rules, multiplication theorem, and two types of addition theorem. These two theorems are just, I'm going to describe them, explain them, how they are used, and I'll just apply them here in solving the questions. So both multiplication rules as well as addition theorem, multiplication theorem, these two theorems are applied for these two kinds of theorems. So first I'm taking, this is briefly I have described, but now let me take them in detail. So just I'm again repeating, there are two types of theorems. There are two important theorems of probability. First is the addition theorem, second is the multiplication theorem, right? Then the rules for these theorems. What are the rules here? First rule is addition rule is for simultaneous trials or simultaneous occurrence of trials. When two or more than two events are happening together simultaneously at the same time, they are happening, right? And here one event has occurred, then other is occurring. This is consecutive event. Multiplication law is applied for consecutive events or consecutive trials. Consecutive means one after the other, consecutive trials, right? This is the basic difference between addition rule and multiplication rules, right? So basic rules, consecutive trials here they are simultaneous occurrence of the trials. Then further they are divided into two parts. That mutually the events which are simultaneously occurring, they may be mutually exclusive events, and they are partially overlapping events. Something is common between two or more than two events. Then what is the addition theorem? I'll talk about, okay, how that is used. And this multiplication theorem is also applied in two cases. What are the two cases? Consecutive events when they are independent events. Then what is the theorem? How to apply that? I'll just explain that theorem also. And then is dependent events. When the two or more than two events are dependent, I mean one occurrence of one is affecting the occurrence of other, or one event has occurred, then other is occurring, influencing the first one. In that situation, both are dependent events, okay, or they are dependent events. So in case of dependent events, I have to describe it. What is the multiplication theorem? Okay, now let me take one by one. First, addition theorem, let me define. After that, multiplication theorem, both of them. So first is addition theorem, let me take. So what are the addition theorem? First for mutually exclusive events, as I have talked about. So addition theorem for first case was mutually, when two or more than two events are mutually exclusive. Mutually exclusive events. And mutually exclusive events are there. In that situation, what are the events, or what is the probability of them? If two events, let me take two events, let me take A and B, are mutually exclusive, then A intersection B means common between them. Simultaneous occurrence of them is a null set, is a phi null set. It is a null set. Null set means nothing is common between them. They are mutually exclusive events, null set. Therefore, probability, this implies that the probability of A intersection B will be 0. Why? 0 upon something, 0. So this is null set because it's a null set. Nothing is, no sample points are there. No sample points found common between them. Okay, so the two events are mutually exclusive, and A intersection B will be 0. Right? Probability of A intersection B will be 0. I mean, they are mutually exclusive. Nothing is common between them. Both are just occurring one after simultaneously they are occurring, but nothing is common. No sample point is found common between them. Okay, this means this important point. Then, therefore, the probability of two or more than two events is given by, therefore, the probability of two or more than two events when they are mutually exclusive. So formula is what? What the formula for them? The probability of A, let me take two events, A union B. Okay, occurrence of both, at least one of them, or either this or both. Occurrence of both event A and B, simultaneously occurrence. Probability of occurrence of both the event is given by probability of A plus probability of B. Means they are added up. The probabilities are added up. Okay, the probability of A union B, or A or B, this is known A or B or both. This is for probability of A or B. The union sign is known as or. Either A or B or both is given by this. So A or B or A union B. This is A union. This is set theory. From set theory you know about this. Okay. From set algebra you know about this, that union sign, intersection sign. Intersection sign shows for common between them, and union says the combination of them. Combination of them. Intersection is common between them, right? And here union of them is simultaneous occurrence of them. Combination, and there is intersection is common between them. This is combination, there is common. What are the common events? A intersection B represent, and A union B represents the combination of the two events, right? So combination of the two events, the occurrence of the two events simultaneously is given by probability of A plus probability of B, or this is known as A or B, right? This is simultaneous occurrence. If there are more than two events, then, and if I prove this, suppose there are two different events here, or we can explain them, that if there is total outcomes are n out of that, or let me take n1 outcomes are there, out of that event A is occurring, okay, or both are occurring, out of n, m1 is favorable to A and m2 is favorable to B, but nothing is common between them, both are separated, then probability of A is m1 upon n, probability of B is m2 upon n, sum of them is probability of A plus probability of B. This is how they are expressed. Okay, so this is for two events only. If there are more than two events, then if there are more than two events, they are mutually exclusive. If there are more than two or n number of finite set of events, then probability of A, let me take, there are n finite, A1 union A2 union A3 union and so on. Right? This is A3 union and so on. It may be A4 here. Okay, and independently this is union AN. So what is union of them? I mean some combination of these events, simultaneous occurrence of all these events, probability of them. Okay, probability of simultaneous occurrence of these events or these finite n events is given by their individual, sum of their individual probabilities. This is probability of A1 plus probability of A2 plus probability of A3 plus and so on plus probability of AN. Here n finite events. Then this formula is applied because they are mutually exclusive events. Nothing is common between them. So probability of A intersection B is 0, which we have already described. Okay, so this is how addition, theorem for mutually exclusive in first kind. Okay, second kind, this is for finite number of events when they are occurring simultaneously and they are mutually exclusive. But second type of this B part, when events are partially overlapping or having common, overlapping. This is partially overlapping or not mutually exclusive. We can say not mutually exclusive. They are not exclusive events. In that situation, what formula is used? Then the probability of two or more than two events or more than two events is given as, first let me take two events. let A and B are two events, then probability of A union B in this case, when they are not mutually exclusive but they have some common, that will be given as probability of A plus probability of B minus probability of A intersection B, means A and B. Probability of A and B. This intersection for AND word, and union is for OR. Okay, and this intersection is for AND. A and B. Simultaneous occurrence of A and B. This is simultaneous occurrence of A and B. Common between them, we can say. So what is common between them? These two events are not exclusive. They are not mutually exclusive, but they are not exclusive. Okay, they are mutually not exclusive. They are overlapping, have some common between them. This formula is given for two events. If there are three events, then let me take for three events or more than three events, then we can apply. Okay, so what is the formula for three events? If A, B and C are the three events, then probability of A union B union C is given by probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C of C intersection A, no problem, plus probability of A intersection B intersection C. This is plus sign here in the end. Okay, these two or simultaneous occurrence of two events is minus with minus sign. How this is with the set theory, we explain that how that is there. Okay, so if there are three events, let me explain this here. If there are three events, this is A, this is B, and this is C. So this is A, B, C, and this is A intersection B intersection C, and this is A intersection B. This is, and this is right. This is B intersection C, this whole, and this is A intersection C, this one, and this is A intersection B in between, and this common between them is plus A intersection B intersection C. How this is? Suppose probability of A. Okay, so we have taken these two portions also, in which A intersection C is added, and A intersection B is also added. Okay, and this which is for triple intersection, A intersection B intersection C, is also added up in A. Probability of A. Probability of B, again these two are added up. In probability of C, these three portions again added up. I mean these two, A intersection C, B intersection C. Okay, so every this is added up two times in case of A, in case of C. Right, so one time it is to be subtracted. Alright, so this is subtracted, A intersection C here, A intersection C is subtracted here, probability of this. Because this is two times added up when we took A and when we took C. Okay, so and this intersection is all the three times it is added up. Is added up. Okay, so when we are taken A intersection C, then it is subtracted, minus sign. A intersection B is subtracted. A intersection this when we take A intersection subtracted A intersection B, then again this. So all the times this intersection of all the three is subtracted finally. It is to be added up because this whole area combination of all the three denotes A, only B, only C, and this A intersection B into A, B intersection C, A intersection B, and intersection of all the three. Okay, so when we subtracted A intersection B or B A intersection B, then both the times this is also subtracted. Okay, so this portion is subtracted in all the times. In this also, in A intersection B also, this triple sign is subtracted. Okay, so in that situation we have to add this also. Okay, so this has be explained. Just to remember this, that whenever there are three events, this formula is applied. So probability of simultaneous occurrence of three events when they are partially overlapping, they are not mutually exclusive, they are inclusive, they have something common. Okay, they are mutually inclusive, they are not exclusive, they are not mutually exclusive. So for that situation we have to use this formula here. Okay, this is what this formula is used. And for four events also, okay, more than four and another four. So this formula is for three events. So we are taking only up to three events. These two formulae are used. Okay, now I'm going to describe that what are the multiplication rules. Okay, so these three formulae for mutually exclusive, we have to add up the probability of the individual events, right? We have to add up them, no subtract in case of mutually exclusive events. But if they are mutually not exclusive but they are inclusive or they are partially overlapping, then their intersection portion is subtracted. In case of two events, minus probability of A intersection B is subtracted. In this case, the two events, when three events are there, then the two events intersection is subtracted, but triple intersection of three events is added up. Probability of the intersection of the three events is added up. The reason is simple, that this intersection section of all the three events is subtracted, is first added up C. In C also all these two portions and this triple sign or triple intersection is added up. In this case also 3 times it is added up. But when we subtracted these three times it is subtracted. Why? Because when A intersection C is subtracted, when probability of B intersection is subtracted, when probability of A intersection B is subtracted, 3 times which was added up, 3 times it is subtracted also. It is to be added up because this portion is also to be included or is included. Triple section of the three intersection of the three events is also is to be included in this whole section. Okay, so only A, only B, only C, and intersection of A and C, intersection of B and C, intersection of A and B, this is to be added up, and this triple intersection of all the three. But why they are subtracted? Because they are added up 2 times. Okay, so 1 time it is to be subtracted. Okay, this is all that point is there. Why 2 times they are added up? Because in case of A intersection C we are added up when we are taking A, when we are taking C. This section A intersection C is added up 2 times. 1 time it is to be subtracted. Similarly here, A intersection B and B intersection C. Okay, or when we take A, then take B, A intersection B is added up 2 times. 1 time it is subtracted. So all the times, these 2 times they were added up, 1 time this will be subtracted, double intersection, and triple intersection is subtracted all the 3 times, they added up, 3 times subtracted, so it should be added up. So that's why this is plus sign here. This will be clarified in case of set theory. Okay, in set theory, when we say intersections, union of the events, intersection of the events, in that situation this is very clear, and this is also here clear, very simple. A person who is just understanding can understand that why this is added up. Okay, so just take this and this and this and this and this and this. In all the cases, this is 3 times added up. But when we take A subtract A intersection C and A intersection B, okay, and A intersection B intersection C, subtracting, then this 3 times it is subtracted. But it is to be added up, so that's why this is plus sign here. Okay, okay, these 2 formulae or 3 these kind of formulae are used for mutually exclusive and mutually not exclusive events. Okay, mutually inclusive, mutually exclusive. The 2 kinds of events are there. Okay, for that we have taken addition theorem. So addition theorem is known as when we are adding them up, right? Union of those events, simultaneous occurrence of at least one event. Both of them are also there. At least one event. This is simultaneous occurrence of at least, probability of at least one event, either A or B or both. This is the formula for that. Okay, so addition formula for them. This is known as addition theorem. Now let us take